Alright, what we're going to do next is to solve the exercise 1.18. The exercise is telling us chapter 7 discusses distributed loads that are expressed in units of force per unit length. If the value of a distributed load is 400 Newton per meter, what is its value in pounds per feet? So this is an exercise in which we have just to transform different kinds of units. The first thing that we are going to recognize is that we are transforming international system units to US customary units. And maybe here I'm going to open up a parenthesis in which I'm going to explain maybe a little bit more about these kinds of units. All the different countries in the whole world manage different kinds of information for them to do actually the same things. So I am from Colombia, and here in Colombia we use international system units for our words, for our maybe for our drawings, for our actually principal for that, for everything. Actually, you're going to a store and maybe you ask for a kilogram of meat, a kilogram of vegetables, and that's how it works here in my country. Now, the US customary units are another type of unit in which countries like the United States of America, that is actually the principal country or the most known country that I know that they use these kinds of units. It actually has its name, US customary units, United States customary units. So they use another kind of let's say it language for them to understand these kinds of information. So now that I've made that clear, I'm going to transform 400 Newton per meter into pounds per feet. So this exercise actually could be solved pretty easy. You just have to Google maybe newtons to pounds and meters to feet, and then you have just to write down the equivalence. So I'm going to eliminate the newtons. That's what I am putting these kinds of units on the denominator part of the division, and transform those into pounds, and then I'm going to eliminate the meters and transform those into feet. I just gotta Google maybe kilograms to pounds, and Google gives me the answer that is I'm sorry what I'm doing, newtons to pounds, and Google gives me the answer that is that 1 Newton is equal to 0.22480. And the same thing here. I actually know the equivalence by just remember it. So I know that 1 meter is equal to 3.281 feet. I put this equation on the calculator, and the calculator gives me the answer. Actually, maybe I got a little bit more complicated than I should, because maybe you just like look for newtons per meter to pounds per feet. Maybe Google gives you the answer. I truly don't know, but this one I do know that it works. So I'm sorry. So this is the easy way. Because of this channel, is trying to teach basics of maybe physics, maybe maths, we're going to do it the old-fashioned way. Why is that? Because I'm trying to teach you the basics of transforming these kinds of units. I don't care if you could maybe, I know for sure that you could do it in Google, and that is the easy part of the exercise, but the principal part for us to understand is to actually learn the basics. So I'm going to start doing this right now. When we talk about a Newton, then we are going to talk about a force. And because of Newton's second law, which is a force is equal to a mass multiplied by an acceleration, I'm going to have that a Newton in international system units is equal to a kilogram, which is the mass unit, multiplied by a meter per square second. And a pound will be equal to a slug multiplied by a feet per square second. Alright, so this is a unit of the US customary units when we're talking about a mass, and this is the units when we're talking about an acceleration. You may be confused because why I'm talking about pounds if a pound is a mass unit. Well, you're actually not wrong. A pound could be described as a mass unit or as a force unit, in which the pound would take the name of pound force. Alright, which is this one. Because maybe in the international system units we have this like information more accurate when we are talking about a kilogram and a Newton. But in the United States or the US customary units, we have the pounds and the force pounds. Actually, in the international system units, we also have the force kilograms. But for this exercise we are not going to talk about those. So it is important for us to understand that we are talking about a force pound. Okay, now that I've made that clear, I'm going to transform kilograms per meter divided by square second divided by meter. Remember that I have here the Newton, and I'm going to divide it by the meters. So this part of the equation is the same one as this one, and the meters are right here. I'm going to transform those into slugs per feet divided by square second, and I'm going to divide that by feet. Alright, now for me to do that, I'm going to transform this division in a simpler way. I just gotta imagine that these meters are divided by 1, and I'm going to multiply the denominator of this part, which is the square seconds, by the numerator part of this division, which is the meters. And I'm going to do the same thing here with the kilograms per meter, and I'm going to multiply by 1 which is equal to kilograms per meter. So the result would be kilograms per meter divided by meter per square second, and multiplied by square second. Alright, and I'm going to transform those into slugs per feet, multiplied by feet, divided by feet, multiplied by square seconds. Alright, now I'm going to transform 400 of these ones. Paste, copy, paste. That means copy and paste in Spanish, which is my native language. And I'm going to multiply this by kilograms on the denominator part of the equation, transform those into pounds. And then I'm going to write down this on red. I'm going to eliminate the meters, these ones, transform those into feet. And I'm going to do the same thing here, meters. So because of these meters are on the denominator part of the equation, I gotta write it down on the numerator part of the equation and transform those into feet. But if you like analyze what I just did, I'm going to multiply by a number and then I'm going to divide it. Why is that? Because, for example, I have X quantity of feet and Y quantity of meters. This relation actually is going to be the same. So Y quantity of meters will be equal to X quantity of feet. So I'm going to multiply and divide the same number. What I could do is that I just could eliminate this part of the equation and this is going to be equal to 1. So this is not going to change anything from the principal part of the equation. Alright, so I just gotta know the equivalence between kilograms and slugs. I'm so sorry, this is not a pound. I'm transforming those into slugs, as we just noticed here. So the answer would be, and this is because I've memorized it, 1 slug is equal to 14.59 kilograms. And I just gotta do this I just gotta write this equation on the calculator. So it would be equal to 400 divided by 14.59, which is equal to 27.41 slugs multiplied by feet divided by feet multiplied by square seconds. Alright, and as we just explained, this part of the equation and this part of the equation will be equal to 400 Newton per meter is equal to 27.41 force pounds per feet, which is the value that I've been asked for, that I've been asked to look for. And that's how this exercise could be solved.